Interfaces. Interfaces and abstract classes provide more structured way to separate interface from implementation. Such mechanisms are not that common in programming languages. C++, for example, only has indirect support for these concepts. The fact that language keywords exist in Java indicates that these ideas were considered important enough to provide direct support. First, we'll look at the abstract class, which is a kind of midway step between an ordinary class and an interface. Although your first impulse will be to create an interface, the abstract class is an important and necessary tool for building classes that have some unimplemented methods. You can't always use a pure interface. Abstract classes and methods. In all the instrument examples in the previous chapter, the methods in the base class instrument were always dummy methods. If these methods are ever called, you've done something wrong. That's because the intent of instrument is to create a common interface for all the classes derived from it. In those examples, the only reason to establish this common interface is so that it can be expressed differently for each different subtype. It establishes a basic form, so that you can say what's common for all the derived classes. Another way of saying this is to call instrument an abstract base class, or simply an abstract class. If you have an abstract class like instrument, objects of that specific class almost always have no meaning. You create an abstract class when you want to manipulate a set of classes through its common interface. Thus, instrument is meant to express only the interface, and not a particular implementation, so creating an instrument object makes no sense, and you'll probably want to prevent the user from doing it. This can be accomplished by making all methods in instrument generate errors, but that delays the information until runtime and requires reliable exhaustive testing on the user's part. It's usually better to catch problems at compile time. Java provides a mechanism for doing this called the abstract method. This is a method that is incomplete, it has only a declaration and no method body. Here is the syntax for an abstract method declaration. A class containing abstract methods is called an abstract class. If a class contains one or more abstract methods, the class itself must be qualified as abstract. Otherwise, the compiler gives you an error message. If an abstract class is incomplete, what is the compiler supposed to do when someone tries to make an object of that class? It cannot safely create an object of an abstract class, so you get an error message from the compiler. This way, the compiler ensures the purity of the abstract class, and you don't need to worry about misusing it. If you inherit from an abstract class and you want to make objects of the new type, you must provide method definitions for all the abstract methods in the base class. If you don't, and you may choose not to, then the derived class is also abstract, and the compiler will force you to qualify that class with the abstract keyword. It's possible to make a class abstract without including any abstract methods. This is useful when you've got a class in which it doesn't make sense to have any abstract methods, and yet you want to prevent any instances of that class. The instrument class from the previous chapter can easily be turned into an abstract class. Only some of the methods will be abstract, since making a class abstract doesn't force you to make all the methods abstract. Here's what it looks like. Here's the orchestra example modified to use abstract classes and methods. You can see that there's really no change except in the base class. It's helpful to create abstract classes and methods because they make the abstractness of a class explicit, and tell both the user and the compiler how it was intended to be used. Abstract classes are also useful refactoring tools, since they allow you to easily move common methods up the inheritance hierarchy. Exercise 1.1. Modify exercise 9 in the previous chapter so that rodent is an abstract class. Make the methods of rodent abstract whenever possible. Exercise 2.1. Create a class as abstract without including any abstract methods and verify that you cannot create any instances of that class. Exercise 3.2. Create a base class with an abstract print, Method that is overridden in a derived class. The overridden version of the method prints the value of an int variable defined in the derived class. At the point of definition of this variable, give it a non-zero value. In the base class constructor, call this method. In main, create an object of the derived type, and then call its print method. Explain the results. Exercise 4.3. Create an abstract class with no methods. Derive a class and add a method. Create a static method that takes a reference to the base class, downcasts it to the derived class, and calls the method. In main, demonstrate that it works. Now put the abstract declaration for the method in the base class, thus eliminating the need for the downcast.